I will introduce Professor María Carmen Garrigós. She holds a PhD in chemistry and is full professor in analytical chemistry at the University of Alicante since 2008. She has multidisciplinary expertise in analytical chemistry, polymer science, and food science. She's also co-director and currently responsible of chemical analysis, extraction of active compounds from natural sources, and biomaterials formulation in the University of Alicante Nanobiopol Group. She's also experienced in coordination of national and leadership in Horizon 2020 projects. She is the principal investigator of the University of Alicante in the EcoFanco project. And in this workshop, she will present microwave and ultrasound-assisted extraction as potential green techniques for obtaining valuable compounds from agro-food waste valorization. So please, María Carmen, the floor is yours.
Thank you very much, Mara, for this kind introduction and also for giving me the opportunity to present this, to do this presentation. I think I have already shared the presentation. Can you confirm that you can see it in full screen, please?
Yes, we can. Thank you.
Okay, thank you. Okay, so as Mara already introduced, this is the topic of my presentation. So I will try to point out the advantages of using sun-grid techniques, such as those based on microwave or ultrasound, in order to obtain variable compounds from food waste valorization. In order to reduce food waste, some examples of high added value compounds are those obtained from different agro waste that you can see here, in particular colorants, essential oils, lipids, polyphenols, and phenolic acid are key examples of these high value added molecules that could be obtained from different agro-food residues and byproducts in order to produce different interesting bioadditives, such as those that you can see here, bioplastics, biocolorants, biofuels, and so on. The number of food waste that is generated is really increasing every year, and in particular, a high quantity of food waste is obtained from the consumption, but also different quantities that you can see here in this sector figure could be obtaining also from the primary production and post-harvesting, as well as for the distribution and manufacturing. So the number of potentially valuable compounds in food waste is really huge. You can see here in this scheme some different examples that different molecules that could be extracted by using green techniques in order to obtain different valuable applications. Just as an example, it is estimated that when processing the orange juice, a 50% of waste could be generated and this waste is rich in different valuable compounds such as cellulose, pectin, limonene, and terpineol, for example, that could be used for different valuable applications. The main challenges for the valorization of food residues and byproducts lies on the optimization of different efficient and sustainable extraction methods and techniques for that purpose. Considering conventional extraction, that is usually based on the use of high temperatures and long times, or maceration at room temperature for even days, it has some drawbacks, such as the use of long extraction times, the possibility of thermal degradation of the active compounds, and the use of high amount of organic solvents. So, for this reason, in the last years, different alternative green extraction techniques has been emerged, such as those based on supercritical fluid, pressurized liquid, microwave, ultrasound, or subcritical water extraction. In particular, these techniques use short extraction times, a low amount of organic solvents, and they have a higher selectivity and extraction yields compared with the use of conventional extraction techniques. In particular, microwave-assisted extraction is based on the use of microwave ionization radiation, causing a molecular movement of the particular target molecules by ions migration and dipolar rotation. To have, let's say, a high efficiency here, it is recommended that the solvent should absorb the microwave radiation. And we mainly obtain two different phenomena: the rupture of hydrogen bonds in dipolar molecules by the free release, and a physical modification and good penetration of the solvents through the molecular structure due to the different pressure that we can obtain here. Comparing the conventional heating and microwave heating, as we can see here in this figure, we have an inverted temperature gradient, let's say, because when you use conventional heating, the temperature of the outside surface is greater than that of the inside, but the phenomena is really different when you use the microwave. So we obtain a very direct heating that it's very efficient. And in particular, in order to have high efficiency, and you can see here, and having a low energy consumption and supposing the use of a green process as well. Different configurations can be used when we use microwave-assisted extraction. Here you can find some of them. We can use an upper system that we can work at atmospheric pressure that has a lot of advantages. We can use also a solid phase reactor in order to perform synthesis by using microwaves. We can even use microwave-assisted hydrodistillation, for example, for the extraction of essential oils without needing any solvent, or we can use a closed system configuration when we can really increase temperature and pressure for some specific applications. Regarding the ultrasound, here we mainly use the focus of some ultrasonic waves by using an ultrasonic probe and a generator, and submerging this ultrasonic probe into a liquid that contains our sample to be extracted. And here we use the cavitation phenomena produced by the ultrasounds to increase the formation of different cavitation bubbles into the liquid until we arrive to a critical size where implosion took place. And this high energy that is generated into the liquid can be used for different purposes, such as for extraction, to produce nanoparticle dispersion, emulsification, and so on. And we'll see some examples later on. So after this introduction of these techniques, my idea is to give you some brief applications of the use of different techniques. Here you have, for example, some examples of different valuable molecules that could be obtained from different food waste by using these green techniques. The first example that I want to show you is those based on the fungus chain project, which is a project financed by BBI. The idea in this project that has ended I think, if I remember well, 1 month ago, is the reuse, the valorization of mushrooms in order to obtain different potential value molecules by using a biorefinery approach. Here you can see a scheme of the different compounds that were obtained, by using a cascading approach. In particular, by using microwave-assisted extraction, we have obtained different antioxidants and antimicrobials, as well as lipid and oil that were used to obtain polyols as well. Here you see one slide summarizing some of the results. For the lipids extraction, we use microwave by using ethyl acetate and ethanol, which is a greener solvent, compared with the most common use, which is based on other more toxic solvents. And we obtain some lipid profiles mainly based on these 4 main fatty acids that you can see here. And then a subsequent extraction was performed also by microwave in order to obtain the polyphenols by using ethanol water mixtures. And as you can see here, we obtain a really high yield, and also polyphenols with having different antioxidant activity, which was tested by different antioxidant assays. These obtaining value molecules were used to obtain different applications, such as those that you can see here, based on cosmetic products with antimicrobial and antioxidant performance, different enriched food supplements for elderly and sport men, based on the use of proteins, and also bioplastic films were used as bag, mulching, and gloves. Another project related with the use of different valuable molecules from food waste is the Barbara project, which was also financed by BBI. The idea here was to obtain different additives, bioadditives, in particular natural dyes, fragrances, and microbials from different food waste that you can see here, such as broccoli, pomegranate, lemon, and almond. And then these additives were incorporated in different biomatrices to obtain different products for construction and automotive applications based on 3D printing technologies. For example, from lemon, you can see here that we use an over and sequential process to firstly obtain, by using microwave-assisted hydrodistillation, the essential oil. We really showed very good antimicrobial properties, both for when it was tested against gram-positive and negative bacteria. And then we perform a sequential extraction by microwave using ethanol water mixture to obtain the pigment, which was mainly rich in different metabolites, such as those that you can see here, eriocitrin, diosmin, and spirilline. Regarding the pomegranate, we also obtained two different bioadditives. One was based on the processing of the arils and the juice of the pomegranate to obtain different anthocyanins that are really well known to have a particular behavior with having different colors with pH. That is very interesting in order to obtain these different color aesthetic properties for the polymer samples, and you can see here. And also regarding the pills, we process it then by microwave assisted extraction in order to obtain microbial tannin extract that was very rich in punicalagins and showed a very good bacteriostatic effect for against Staphylococcus aureus, as you can see here. A similar behavior was observed for the pigment as well. Another examples that I want to show you is this one, this is a research that was performed for our research group for the valorization of Aloe Vera agro waste in order to obtain electrospoon nanofibers. As you can see here, the idea was that we obtain a rich extract, polyphenols extract from the Aloe Vera waste by microwave assisted extraction, and then we incorporate it in this biopolymer in order to produce some nanofibers. So as you can see here, by electrospinning, we show that the thermal stability of the extract was really increased, and also the materials, the obtained materials, had a very good antioxidant behavior when you use 5% of this bioextract or more. Another application also by our research group is to obtain selenium nanoparticles. In this case, we have used cocoa waste as the food waste here. The idea was to obtain also by using microwaves a reducing and stabilizing agent by obtaining an extract at acid conditions, which were rich in polyphenols, pectin, and proteins, that combined with a metallic precursor that you see here was enough to obtain really selenium nanoparticles with a spherical behavior, and as you see here, a very low diameter. And also these nanoparticles showed a high antioxidant capacity that was stable for 2 months at 4 degrees, as you can see here in the results, considering the antioxidant activity. Another application that I want to show you today is the conversion of lignocellulosic biomass to obtain valuable molecules with microwaves. In particular, the idea is that we can convert the polysaccharides that we have in this food waste into different reducing sugars by using very high temperature processes, but with a very few time, as you see here. For example, we can obtain levulinic acid from different biomass resources, such as those based for post-harvest tomato plants. And also, as you see here, we can obtain lactic and glycolic acids by using just 2 minutes by using microwave heating compared with 4 hours for the conventional heating. These lactic and glycolic acids can be used as well in order to produce polycondensation by using as well microwaves in order to obtain different yields, as you can see here, and different polymer composition made of the different quantities that we can put of these different monomers. Regarding the ultrasound, as you can see here, this is a green technique that can be easily scaled up, which is very important in order to transfer, let's say, the results for an industrial processes. And this green technique is very valuable for different processes. I have highlighted here some of them in order, for example, to homogenize different samples, to do some dispersing of the agglomeration, to perform some emulsifying of the solutions, wet milling and grinding, and also to perform extraction, or for example, to do some synthesis, also considering the sonochemistry here. In this slide, you can see some applications and some photographs, micro photographs obtained for the use of this ultrasound technique in order to do some wet milling and micro grinding. So the idea is that by using this technique, we can really reduce the particle size of a specific sample, but without having the drawbacks of other techniques that we can use in terms of some deterioration of the active molecules or some thermal degradation. Another example that I want to show you today is the combination of the ultrasound or microwave assisted technique with deep eutectic solvents in order to extract valuable molecules. In particular, this application has been done by our research group, considering the horchata de chufa byproducts, that it's a particular drink that we have here in Spain, which is protected from in the origin of the generation of this drink. And the idea here was to combine the ultrasound and microwave by using eutectic solvents, obtaining by combining the, as you see here in this table, the toluene chloride as an hydrogen bond acceptor, and different solvents, urea, propanediol, glycerol, and ethylene glycol as a hydrogen bond donor. All of them using a molar relation of 1:2. So you can see here in this graph the results obtaining when using these different deep eutectic solvents. And if we compare this result when those obtained in this table that you can see here by using just microwave and ultrasound with ethanol water mixture and without the use of these eutectic solvents, we clearly see that an increased antioxidant capacity was obtaining by combining these green techniques with these eutectic solvents, and also that this antioxidant capacity was higher for the tuber compared to the plant residue.
Excuse me, María Carmen, you have 5 minutes left.
Okay, thank you. So finally, in this slide, you see some results for the application of microwave and ultrasound techniques for this project, the DecoFunco project that we are discussing today. And in particular, first we see here that we have extracted polyphenols by combining with the use of Bose-Benken design, statistical experimental designs, by applying microwave and ultrasound techniques. And then after different steps that you see here, precipitation and the separation of some possible interferences, we have obtained an extract rich in different polyphenols compounds, mainly in arginine, rutin, and chlorogenic acid. As you can see here, the results obtained by both techniques, we obtained good results, but in particular, higher performance by using microwave-assisted extraction. Regarding the extraction of fatty acids and tocopherols, we use also microwave and ultrasound, but we have some experimental problems with the ultrasound, so we decided to go just here for the use of microwave. And you can see here the results obtained and the specific profile of the fatty acids that we obtained here. That was very interesting. And also a very interesting result is that we obtained a high quantity of, in particular, gamma tocopherol. So we think that this fatty acid extract could be very valuable to be used also for its antioxidant performance. Just to conclude my presentation, I want to highlight that the valorization of agro-food residues and byproducts is a field with really high potential in order to obtain different valuable molecules for different advanced functionalities. And for this purpose, the development of innovative, fast and efficient methods for the extraction of these compounds is needed. And in particular, microwave-assisted extraction and ultrasound-assisted extraction, I think could be considered essential green techniques for the development of these efficient methods for in order to obtain high extraction yields. So I hope to clearly have highlighted that these different agro-food residues and byproducts can have a great potential to obtain different valuable molecules and applications. And finally, I would like to thank you for your attention and show a photograph. This is my research group. Unfortunately, we all have the mask because this is what, well, you already know is happening now in these times. And but nevertheless, I wanted to show you a picture of our research group, and thank you for your attention.
Thank you, María Carmen, for your wonderful explanation on the advantages of and application of compounds extraction methods based on microwave and ultrasound technologies. And we have a question from the audience. Oscar Rodriguez asked and said that I am very pleased for the presentation of Professor María del Carmen. And I'm reading the question. So my question regards to the industrial application of both technology, microwave or ultrasound. Is the industry using these techniques or they are only in laboratory level? Is ultrasound-assisted extraction and microwave-assisted extraction feasible from the economical point of view?
Okay, thank you, Oscar. It's a very good question. In particular, I think it's the key question, okay? Well, let's say that these techniques, microwave and ultrasound, of course, are very developed, let's say, at lab scale. But I have to say that I think, yeah, it is a reality now to apply this technique at an industrial level. In particular, the ultrasound technique, it's more developed at this high scale. But I know that also the microwave extraction can be used at a pilot scale. So yeah, it is a reality that we can use these techniques also for these industrial processes.